Hi there, looking at B2, which is loaded components. We're going to look through some of the theory here. Then you can try some exam questions and see how to approach it in a consistent manner, knowing the simple things to look for when you see a question. So the stress-strain forces, Young's modulus of rigidity, that's what this covers. You need to, first thing to know is the difference between direct and shear. Okay, so there's the definitions. You can pause that and copy that down or read it if you want. But for direct forces, you would use direct stress and direct strain, force over cross-sectional area, and that's changing. Little delta is changing, length divided by length. So that otherwise, change in length is otherwise known as extension. So extension over length is direct strain, and force over cross-sectional area is direct stress. So for shear, you've got the same idea, force over area, and strain is again your extension over length to a degree, and then that's giving you these funny Greek symbols which you might not be totally comfortable with, but it's the same approach. You've just got to see whether it's direct or shear. These are what we call ratios. So your Young's modulus is the ratio of the stress divided by the strain, and your modulus of rigidity is the ratio of your stress divided by the strain for shear forces. Okay, so it seems straightforward. It's just force over area for both of them, shear stress and direct stress. But which force to use and which area to use, that's the challenging bit, I suppose. Here's an example of direct stress or direct forces and shear forces. So shear forces will try and cut across something, like shears, scissors or shears. Garden shears, that's what scissors are called. So the direct forces try and pull something apart. They'll stretch something, make it longer, whereas the shear forces try and rip it apart, I suppose, cut across it. This will be a very simple example of direct forces. That would lead to direct stress and direct strain. If you think about the formulae, you've got your direct stress, which is your force over your area, and your direct strain, which is extension over length. So all we'd need is the force, got that, and the area. Well, there's the diameter. Half the diameter, get the radius, convert it into meters, and then you can use pi r squared to get the area, cross-sectional area. So that's the stress covered. Strain is extension over length. So if they were to tell you how much it's extended by, and then you could use the original length if you were given it to work out the strain. Direct strain. Here's an example of the strength of a material. So if you want to know how strong something is, we're talking about how much it can take before it breaks. So that would be the tensile and shear strength, so the stress or strain that it reaches before it snaps. Now here is an example of shear forces, but instead of the example here, where you've just got one force up and one force down, we've got two forces on one side. Now that's a special circumstance here, that's a special case where this is known as double shear. So we would use half the typical force. The correct force to use there, I'm just going to say this so you know it for the assessments, you'd use the 10, not the 20. I mean, technically, they'd typically describe it as using twice the area. But if you think of stress as force over area, twice the bottom number or half the top number gives you the same result. Okay, so here's an example of a typical. The direct stress ones typically go don't have a diagram, and they'll just go into a little bit of detail about, you've got the length, you've got the extension, so you can easily work out extension over length there, which gives you the direct strain. Couldn't be easier, that one. But here you've got a single shear. It's an example of single shear. So whatever F was there and there, that's the force you would use. But here is an example of single shear. Yeah? So the force you would use is 15,000 newtons. Here you've got double shear. So double shear, you notice in that it's half the force. So the value that we'd use for that force, the force here, shear stress, whatever F was, you'd use half that. If that was 20 kilonewtons, you're using 10 kilonewtons. Okay. here's an exam question with that. So it's the 10 that you use in your calculation. Now here, I mentioned that there's two questions really. One is what force to use, and the other is what area to use. And here is an example of not a pair of scissors, but like a hole punch. Now the area to use is not the area that I'm kind of shading in now. The area to use is this area. So imagine you wrap that with a little ribbon. It's the cross-sectional area of that. So the area of the ribbon that you wrap it in. Okay, because that obviously means that if all we took was that area, then it could be the paper could be as thick as you like, and it would still give you the same value, which doesn't make sense. The thicker the paper, the harder it is, and the bigger that area will become. So it's the area of this bit here that I will be shading in here with the cursor. Okay, so that's it. So if I go back to the start and we look at these formulae, for direct stress, force and area, it's always just a cross-sectional area, pi r squared. These are the easier questions. Extension over length, you'll just be given it pretty straightforward. It's the shear stress and shear strain which is more complex. So for shear stress, the force, if it's single shear, the force is just the force that you're given. If it's double shear, it's going to be half the force that you're typically given. And then the area, well, if it's the area of something that you're cutting through, like the hole punch, then it's the area that I've just explained. It's not the area, the first one that you might think. Okay, and then Young's modulus, the modulus of rigidity, are typically is two ways that you can approach it. Either you work out the stress and the strain, then you just divide one by the other to get that modulus. Or the second approach, they might give you the modulus of rigidity, and then they might give you the strain, and then just get you to work out the stress. So it'll just be a simple rearrangement. Okay, so that's the basic theory. Hopefully you can go away there, try a few of the exam questions, and then when you've tried them and see the solutions, hopefully that'll be helpful to you. Okay, thank you.